Now the topic is linear differential equations, second and higher order. Till now we have solved the solutions of first order first degree differential equations. If the differential equation order is 2 or more than 2, then how to solve that differential equation? We have different methods. Now here I will consider the general form of the linear differential equation of higher order. This is important, very important. By using these differential equations, we can solve many applications, electrical circuits and bending of beams, and many applications we can solve. These are the best two examples. The general form of the linear differential equation of higher order is d power n y by dx power n plus p1 into d power n minus 1 y by dx power n minus 1 plus p2 into d power n minus 2 y by dx power n minus 2 plus so on pn into y equal to q of x. This is the general form of the linear differential equation of higher order. Here observe this one, p1, p2, p3 and so on pn, and last one q of x. These are the continuous differentiable functions, continuous functions. Then this differential equation is called linear differential equation of higher order. Suppose p1, p2 and p3 so on pn are real constant, then this is nothing but ordinary linear differential equations. This is called ordinary linear differential equations. Then how to solve? We have ordinary differential equations. How to solve this ordinary linear differential equation? Means we have special method. Once again I am taking that differential equation, d power n y by dx power n plus p1 into d power n minus 1 y by dx power n minus 1 plus p2 into d power n minus 2 y by dx power n minus 2 plus so on pn into y equals to q of x. Here in this differential equation, observe the important term, p1, p2, p3 so on pn are real constants, means numbers, and q of x is nothing but function in terms of x1. Then if you want to solve this differential equation, the general solution of this differential equation is y equals to yc plus yp. yc plus yp. yc is nothing but complementary function and yp is nothing but particular integral. Means the solution he has divided into two parts. The first part is complementary function, the second part is particular integral. Means first of all, if you want to solve this problem, half problem is complementary function, the next half problem is particular integral. Means we will focus on complementary function first of all. After that, how to solve the particular integral, we have some separate methods are there. 5 to 6 methods are available to calculate the particular integrals. First of all, we will learn how to calculate how to construct the complementary function. Now, for calculating the complementary function from the differential equation, you consider different type of differential equation. The same differential equation we will modify it, means half part we will consider. The same differential equation while calculating the complementary function, consider d power n y by dx power n plus p1 into d power n minus 1 y by dx power n minus 1 plus p2 d power n minus 2 y by dx power n minus 2 plus so on pn into y equals to 0. The last term, observe this one, 0. But actual differential equation is q of x is there. Means we are going to solve half problem, means complementary function. We are calculating the complementary function, means q of x equal to, I am taking directly 0. Now If you are taking 0, then we will consider some differential operators. These are very, very important. This is the first step in calculation of complementary function. Capital D equal to d by dx means differentiation with respect to x. D square equal to d square by dx square. Capital D square equal to d square by dx square. D cube equal to d cube by dx cube. So on. D power n, capital D power n equals to d power n by dx power n, means n the differentiation with respect to x. You put all these differential operators in the above differential equation, means in that equal to 0 form, means that equation becomes as d power n into y plus p1 into d power n minus 1 y plus p2 into capital D power n minus 2 into y plus so on pn into y equal to 0. Now I will, from this equation I will consider y is common. Then it becomes d power n plus p1 into d power n minus 1 plus so on pn into y equal to 0. Means it becomes f of d into y equal to 0. F of capital D. Means this, in place of capital D I will consider only small m, means f of m equal to 0, means directly you have to construct, means you have to take this equation f of m equal to 0. This equation is called auxiliary equation. Means if you want to construct complementary function, means you should consider first of all auxiliary equation. The auxiliary equation is once again f of m equal to 0. Auxiliary equation f of m equal to 0, means you calculate the roots of the auxiliary equation. We have 5 types of complementary functions are available. It depends on the roots of the auxiliary equation. It depends on the roots of the auxiliary equation. If the roots of auxiliary equation are real and distinct, all are different, we have one type of complementary function. If the roots are equal, we have another complementary function, the second method. If the roots of the auxiliary equations are complex numbers or imaginary numbers, we have one more method. If the roots of the auxiliary equations are repeated, we have one more type of complementary function. These are nothing but different formulas for getting complementary functions. It depends on the roots of the auxiliary equation. The last one, the same thing, how to construct this complementary function I will consider. This is auxiliary. At last I have taken here f of m equal to 0. This is auxiliary